Now, for as long as human beings have known that the stars aren't just little balls of light in the sky, but that some of those lights are actually planets far, far away, we have wondered, what if there was life in the universe beyond us? The search for life has been a never-ending quest in a universe that is much larger than any astronomer ever previously conceived, something we are still trying to understand. But instead of searching planet by planet for life forms themselves, astronomers are searching for planets that are habitable in the first place. Now, despite the vast expanse of the universe, the chances of finding something like that are extremely narrow because most planets can't meet even the minimal requirements in order to sustain life. And yet, last week was a major breakthrough for astronomers when they located not one, not two, but 3 habitable planets. To talk more about this discovery, I'm joined now by Ian O'Neill. He's an astrophysicist and space producer with DiscoveryNews.com. Hey there, Ian. So what exactly did the scientists discover in the Lyra constellation, and what can we learn from this?
Well, yeah, you mentioned that in particular was one star system that actually contains 2 planets that are within the habitable zone of that star. Now, this system is of particular interest. It's called Kepler-62, and it's of particular interest because these are the smallest planets that fall within the habitable zone of the star that's ever been discovered. Now, this star is a red dwarf star, so it's kind of different from our star. It's older, and it's smaller, and it's less bright. But these 2 planets actually orbit within the zone around the star that is probably just right, just the right temperature for liquid water to exist on their rocky surfaces. Now, we know very little else information. We only know their orbital period, and we know their size, thereabouts. One is about 60% bigger than Earth, the other one is about 40% bigger than Earth, so they're very close in size, most likely rocky bodies. But that's about all we know. So although it's very tempting to say these are habitable planets, they're certainly not Earth standard.
And we also know that that scientists included in another scientific study, Kepler-69c is another planet that was recently deemed habitable. But scientists have acknowledged that these planets are too far away to really know what they're made of, how dense they are, etc. So how do we know that they can sustain life, essentially? How can we come to those conclusions?
We don't know. This is the main thing. This is the problem we've got, because as you mentioned, they're too far away. Anything really over 800 light years away. I mean, these planets are around about between 1,000 and 1,200 light years away. So they're really out of the scope for any spectroscopic analysis. So we can't actually look at the atmospheres. If they do indeed have atmospheres, we don't even know that. We can't really look into the atmospheres to actually work out whether they got water, whether they contain the oxygen in the atmosphere. We don't know if they got carbon dioxide. We know none of these things. As I say, we only know 2 characteristics, is their size and their orbits. But that itself is very exciting because we know of one planet that's abundant with life, this planet, and it falls within the habitable zone of our star, the Sun. So just using that as a yard post, we can say, well, there is a chance that these 3 planets may well have the right recipe for life on their surfaces. And if life is common throughout the universe, bearing in mind we haven't got a clue if that's true, but if life is common, those are the planets that we'd actually put our bets on. And the likes of the SETI Institute, SETI scientists who are actually looking for extraterrestrial intelligences, they will be directing their radio telescopes at these targets because it's our best bet.
Now, as I understand it, NASA's Kepler satellite is the one that actually discovered them, which is why the star and the planets themselves are actually named after that satellite. And that satellite actually has more than 150,000 stars that it is actually keeping track of. So can you describe to me what the Goldilocks conditions are for a planet to be considered habitable?
Basically, yeah, the star, I mean, Kepler is particularly interested in sun-like stars. I mean, the obvious reason for that is we know our star, the Sun, can support life within this habitable zone because our Sun is kind of they call it an average star. It's certainly not average by any means, but it's not very violent. It doesn't fire out these super flares that irradiate all life on Earth. So we are very lucky in the fact that we're actually here because our star isn't that violent. It's in a middle-age portion of its life. It's kind of plodding along and it's able to support life in its habitable zone. other characteristics of, well, any star can be considered to support life, but with Kepler, it's actually looking for stars that are approximately the same mass as the sun, because the sun, as I said, is a good yardstick for supporting life. And also we're looking for planets that are orbiting within that particular star's habitable zone. So the Goldilocks zone, as it's called, it's not too hot and not too cold. So say if a planet was orbiting outside, further away from the Goldilocks zone, it's likely going to be frozen. So our interpretation of life, so bearing in mind we're talking about life as we know it. So life as we know it on Earth requires liquid water to evolve. So it has to be within this habitable zone. So too close to the star as well, that's no good, because all water would evaporate and it'd just be vapor in the atmosphere. That's not to say that other forms of life may not exist on these planets, but the point is we only know of one type of life, and this is it. So we're trying to look for any clues or any tracers that our form of life exists elsewhere in the universe.
It's a very exciting discovery, although no one's going to end up being there anytime soon. Ian O'Neill, astrophysicist and space producer with DiscoveryNews.com.
Thank you.